What's up, y'all? I'm Adrian, the lead programmer, self-proclaimed lead programmer, and I'm making this video because I want to explain what each role should do to develop this game, or what I expect from each role. Because as a programmer, I only know so many tools in Unity. And so I'm just gonna list what I expect from level design, from art, and from programming. And hopefully this will get us thinking to how to actually make this 3D pinball game, which I made the idea because it seems like nobody else wants to throw out an idea, I guess. So 3D pinball it is. So for level design, what I expect from level design is that they will make levels. And in Unity, levels are scenes. In this blank project, I just made a universal 3D project. It has nothing on it, basically. There's a scene here, right here. It's in the scenes folder. And what a scene is a collection of game objects, right? If you ever use Unity, it is a collection of game objects. And I'm going to explain everything as if you know nothing about Unity, because I'm not going to assume that everyone is a master of Unity, because that's probably not true at all. Most of y'all probably don't even know how to use Unity, but let's roll with it, I guess. I'm going to try and explain this. So yeah, level designers will make scenes. And in the scenes, for specifically 3D pinball, they will each have a new cabinet or a different cabinet. Different pinball cabinets. And this pinball cabinet can either be made up of a collection of game objects. For example, to make a game object, you go to game object and then you choose whatever. Everything in Unity is a game object. Down to the freaking text. That's also a game object. And all a game object is why can't I find the cube? Or is it, oh, a 3D object cube. All a game object is an object, obviously. It has a model as a render thing. And it has a transform. It has a mesh and sometimes a collider. That's what a game object is. So everything in Unity has all of this for the most part. So you can make a pinball cabinet out of, for example, a bunch of cubes, right? Just place them all over the place, you know? Or something that I actually never tried before. I don't even know if it works, but you could make a Blender model of a pinball cabinet. You can make a Blender model of the pinball cabinet because technically the pinball cabinet is a level and also a model at the same time. Because that's all the game is going to be about, is about the pinball cabinet and the ball, I guess. But yeah. So you could make a model, a Blender model, specifically Blender, because Blender works well with Unity, or you could use whatever you want as long as you know how to import the file and we can use it. The pinball cabinet could be just a model and we put collision boxes, right, onto the model. That is supposedly very complex because a pinball cabinet is not that simple. Or you could just, you know, put a bunch of these cubes around. It's fine. But every scene, and I'm going to show you how to make a scene, you do create, and you just left click on any open file, you do create, and you can make a bunch of stuff and also a scene. and then you name the scene like, let's call it level 2, because it's the second scene, and you go into it, save, I guess, and you know, here's the scene. It has nothing in it, and yeah, and then you would just put the pinball cabinet here, or the amount of different objects that make up the pinball cabinet. So 2 ways, but they're all going to use scenes, and that's what I expect the level designers to do. And I imagine that the level designers will also want level mechanics, right? Well, I'd say the programmers will handle that. So you guys y'all request level mechanics, and we will hopefully take care of that. Now, art. What to expect from art? Well, in Unity, there's a lot of art. You can make, for example, you can import textures, which you can also make from Blender. And a texture in Unity, and I'm just gonna make a new folder here just by left clicking, create folder. I'm gonna call it materials. Okay, this is not in the right spot. Let me move this over there. Right. So materials, right? You can create a material, and that's what a texture is. So I'm gonna call it like floor mat. You see these base map, metallic map, normal map, blah blah blah. That's the texture files. So when you make a texture in Blender and you follow some tutorial, you will end up with a base map, metallic map, and whatever. And you would just put those files in like here somewhere, and then you would just drag it to here. I haven't messed with that much because I'm a programmer, I'm not an artist. But you can do that, and we can use that. We as programmers can use this material and put it anywhere else, and y'all can do that too, actually. Another thing the artists can do is make PNGs for UI. Unity UI. Again, it is a game object, so it's like everything else. This image comes in a canvas, but we'll deal with that later. This image, you can swap out the source image right here, and we can just put any PNG in there, and also a material, so a texture as well. So y'all can make, like, draw out the UI for this game, and we can just put it in to any UI we're working with. Another thing is SFX, or sound effects of pinball machinery. This is pretty cool. This is like a very big part of pinball, is how it sounds, right? How it sounds to hit the paddles on the ball. And you would do that with like a .wav file. You would make a sound, and you would make like a sound, a .wav file in a sound editor program or something, and you would just import that here, and we will somehow use that in the game. We can use that too. I've actually never used sounds before, so I'm gonna learn that this time. If y'all make .wav files, I'll try to use it. And lastly, the artists can make shaders. Now that's a lot more complex, but basically, you see this? There's a tab here right beside the inspector. It's called lighting, and you see there's lighting settings, and then over here, this is called lighting settings asset. Yeah, you can make a lighting settings asset, and Unity defaults these lighting settings to the settings folder. And these are like, this right here is a mobile render pipeline, RPA. Can I go into it? I guess not. But it's a pipeline, and if you make one new, you can go into it and like change a bunch of stuff. Not sure how much does a shader. kind of didn't think this through, but yeah, if you know how to make shaders and import them, yeah, that would be cool too. Anyways, yeah, level design, art, all of this stuff is useful for making the game, because the programmers, us programmers, we can use all of this in the game. So yeah, that's cool. Now for programming, because I'm the lead. So if you ever looked in like a Unity tutorial on YouTube or something, the tutorial person will most likely say, okay, for everything you make, for every game object you make, right? They're gonna say, okay, give it like a script, right? Give it a script and like call it like I don't know, player behavior. And they're gonna say this all the time. They're gonna say, okay, make a script for everything. Well, in this case, we're not gonna do that. And instead, we're just gonna use one script for an entire game. Now, this might seem weird, because like it is kind of weird, because Unity basically all the time encourages you to use multiple scripts. But this game isn't that big, and using one script has its benefits, and I'm gonna showcase that. So we're gonna use one script, and now I'm going to go over how to organize this one script so that it is readable, so that we can easily just go skim the script, this one script that has the entire game in it, and not have an issue and not be confused all the time. So yeah, so I'm gonna make a new script. You just type new script, and then I'm gonna say entire game. All right. And the default script, when you make a script for a game object, is gonna look like this. So yeah, this is what a script looks like when you make it fresh. We have 3 things here. Well, 4 things. We have using Unity engine. That's like the files we need for the engine itself. We can ignore that. We have a class here, entire game, mono behavior. Now, this is a mono behavior because it is part of this game object. This script is just made for this specific game object. That's why it's mono. It's one behavior. And that's fine. That's what we need. That's fine. So this class is good. But there are different classes in Unity. If you get rid of this mono behavior, it just becomes a regular script file, or a script file that's not tied to any object. And you could use that, but we're not going to do that. We're just using this one script. Now I'm going to explain how we're going to organize all of this. So first of all, what do we have here? We have a start. Well, this, as is described here, is called once before the first execution of update, after the model behavior is created. So basically, init. We call it init because it's this executes for 1 frame before update. We will use this specific function to initialize data. It's called init because this is where we will initialize all the data. And an update is called once per frame. So this continuously, anything that's in here continuously executes forever and ever and ever until the program is stopped. This is called update because here we are basically changing values of variables over time. So over time, the game will progress. So this is where we'll initialize data, and this is where the game will run. But we need a few more things. Before any of this, we need to define, or we need definitions. Define our variables. So now I'm going to showcase something, a variable type that I'm definitely going to use. And it's called a struct. For any variable, you put its type. In this case, the type is struct. And then you put the name you want to give it. So I'm going to say that this struct is player. And specifically for structs, you do brackets. I do enter and then semicolon. This is a definition for player struct. And what a struct is an object, basically. I can put anything in here. You can define variables, and we can also make functions in it as well. So I'm gonna do that. And that's why these are very useful, because you can put anything in it. So I'm going to define some variables. Now everything in a struct, in Unity specifically, it has to be of access type public. And this is called an access type because this determines where this variable is accessible. So this thing can either be public or private or whatever, but in this case it's public so that I can actually use it over here. So public, let's say game object. Now this game object is the variable type that this cube is made of. This cube is a game object, and this is the type. So you can make game objects in the script, and I'm going to name it obj. So it's easily typable. And I'm going to make some functions. Public void. Now I do the public as the access type because I want to access this all over the place. It's public. And now void, as you see here, this is the return type for a function. So I'm going to say construct. Now, whenever you make a function, you should write down, and you should do comments like this commonly. It's helpful. You should write down what the function of the function is. What's the purpose? So the purpose of construct in this case is to initialize player data. Void means that this function will return nothing. When I execute this function, it's going to return nothing. All right, it's just going to execute. Now I want this function to actually receive a game object that can only access here. It's weird. But I'm going to access the cube game object. I'm going to access the cube and put it in to this game object. Why? Well, just to make it easier to access, I guess. First, I gotta give this function a condition. So I want a game object, and I'm gonna call it player obj. And when I execute the construct function, I'm gonna say obj is equal to player object, to whatever I put into this function. So I said this is a struct, right? And it's an object. Well, this is just a definition of the struct. The struct does not actually exist yet. So I'm going to make it. You put the type and then you put a name. And I'm going to call it D player for some reason. And then you do equal to, and then you say new player. Or new, whatever the object type is. And then pressures parentheses that the player is now a player object. So this now is what we're going to reference everywhere else. So now the player has the construct function. Look at that, it showed up. It works. It works because it's colored. And look at that, when I highlight it, it goes to there. That's one way. That's one way to know that it actually works. But as you can see from this message, it wants a game object. So I'm gonna give it the game object of this model behavior. Now in model behaviors, for some reason, Unity calls this game object, specifically this one right here, because the script is in the cube. It calls it game object, lowercase game object. So this is the object. So what I'm referencing here is the cube. This is the cube. I'm saving it into a game object. And you can only do it, you can't call for this here only after start is executed, because game object technically doesn't exist, blah blah blah, whatever. So now I want to actually use the player in the update. So I'm going to make another function for update, and I'm going to call it something specific like move, right? Because I expect the player to actually do something and I want them to move. So in this function, the purpose is to move the player. And I know this has nothing in it, but just as an example, if move has something in it, you would do whatever struct you made and then dot whatever function you made as well. And so there we go. So yeah, so this right here, this is how I want the code to look like. I'm bad at explaining things, but here's the gist. We're going to define our variables. And by the way, cool tip, these arrows, you can click on them and it will hide whatever function is right next to them. That's pretty useful. But first we will define our variables. So we'll make, structs and whatever, and then we'll make actually make objects out of the variables. And then we will initialize them. We will give the objects data, such as game object right here. And then lastly, we will use those objects in the update. We will change the values over time in the update. Yeah, that's everything we basically need to make a game. It is a lot at first, but once you throw into your head that, okay, we're going to define, initialize, and then update, it just becomes second nature, honestly. And if you notice in the struct, I am initializing and updating and defining in the exact same order that I'm doing it outside of the struct, because that's just how everything goes, I guess. That's just how this works. That's how we're gonna make one script work, and I hope y'all can understand it. And right now I'm going to give y'all some tips, because obviously doing everything in a script, you need to know all of the functions. You need to know a lot of the functions to actually do anything, because in the Unity editor, they really want you to just make an object and then, drag it into somewhere. We're actually going to do a little bit of that. So you see, okay, I'm going to make a new object, and I'm going to call it sphere, right? Test sphere. So I'm going to make a prefab, and these are really useful, and how we're going to basically make this game work with one script. This is the main way. So I'm going to make a new folder, and I'm going to call it prefabs. So test sphere. If you double click on an object when you're not looking at it or whatever, it will zip right to it, by the way. But I'm going to make this sphere a prefab. How do you do that? Well, you just click and drag the object you just made and put it in a file. There, now it's a prefab. You see how this is blue? It's a prefab. So yeah. What is a prefab? Well, a prefab is basically a constant object. An object that you can change in the file, right? And once you do whatever to the sphere, to the prefab, you can then just put it anywhere else, and it will be exactly the same as any other copy of that prefab. This is really useful because we can just initialize everything in the script. I'm going to now put the prefab into the script. So the way I'm going to do that is make a public variable. Now, when you make something public in Unity, I know we made it public here, right? So that we can access it everywhere else. But that doesn't really work for scripts, for structs. It only works outside of that. When you make something public, you can now, you will then be able to access it right here on the script. You'll see what I mean. So I'm going to do public game object. So a prefab is still a game object. So to get it into the script, we say public game object. What's it called? A sphere prefab. Gonna call it sphere prefab because that's what it is. And that's it. That's all it is. And I just saved the file with Control S. Always do that. And then you go back to the Unity editor and you can Control S here as well. So I just made that public thing, and I'm gonna go back to the script now. And you see here we have sphere prefab. It's empty and it wants a game object. So guess what? I'm gonna put the prefab into that slot, and now it's there. So now this sphere prefab is the test sphere prefab. Now when we make prefabs, you usually want to delete the original one from the scene because you're going to initialize it to the script. So to initialize a game object, right, a prefab, it's a specific command. Well, I'm gonna do this real quick. All right, I need to store the prefab into something. So the prefab is here, right? But that's all it is. It's a prefab. We need to initialize it. When we initialize it, we're gonna get a game object. So I need to say like sphere. So we got this game object ready to take in a game object, right? It's not initialized yet. I just defined it. So we're gonna take this. I'm gonna take this sphere prefab and use it. So it's instantiate takes in a game object. In this case, it's a prefab of sphere. It also takes a transform. Dot identity, whenever you see that, it basically just means 0, 0, 0. It's nothing. And it also takes a rotation. So I'm going to do quaternion dot identity as well. Okay, so instead of a transform, I put a vector 3. And a vector 3 is basically a position in 3D space. 3 dimensions. X, Y, Z. That's why it's a vector 3. But anyway, this is a position and it's 0, 0, 0. So I instantiated the sphere prefab into the sphere object. So now we have a reference to a sphere object. So now I can use this however I like. I can move it around and stuff. And yeah, that's how we're going to use prefabs in the script. And this will usually be inside a struct, like this. So this sphere game object will be inside its own struct, like right here or something in the struct. all the code should be in its own structs, right? So we're going to make a bunch of structs and it's all going to have a code. And at the end, if all things go well, I'm going to open up one of my games that I'm working on right now. And I'm going to show you how I use this organization to make my own game. So here I am in my game. You see, there's the game object and a bunch of stuff here. These are all prefabs. But the one script, I only use one script for this game, is right here. And you see there's like prefabs for camera and stuff. If we go in here, I'm gonna turn down the zoom. There's a lot of code. But if I hide all of this garbage, you will see everything is organized exactly like what I just showed y'all. So we have the definitions right here, the structs and also enums, and all the objects I made. And then we have the initialization of all those objects, and then we update them with like .move, .rotate, .search, whatever. And that's it. And all the functions are in the structs. Oh my god. So yeah. That's basically it. And I don't expect the programmers or anyone to really catch on to this quickly, which is why I chose 3D pinball, because 3D pinball sounds straightforward and yeah, not too hard. So yeah, hopefully I explained that well.